professor. My name is Ramtin with the SIMD 1014192226. I'm going through the second assignment instructions to read line by line and explain how did I get this assignment done. So for here, we're just importing the CSV file, printing it, getting a summary from the dataset. General idea is 150 rows, 5 columns. This species column is the target label. Over here we have the head functionality, only prints out the first 5 rows. Over here we are basically mapping through each name and give it a number. And the reason for that is because machine learning models deal with numbers and not strings. Therefore, we are giving them different numbers instead of each name. Then we print out returning the dataset once again to confirm that the species column column values have been changed from strings to numbers. The first 5 rows the same. Over here we're just putting the first 4 columns inside the x variable, and the target column or the label inside the y variable. And how it works is as there's only a semicolon over here, a column is over here, we are getting all the rows and we are getting all the first 4 columns excluding the -1, which would be the target column. And in the y variable we are only getting -1 as a column. Then we're importing the train test split, which is from model selection library in scikit-learn. And what it does, it basically takes the x variable, y variable, the test size, which is 0.2 over here as we mentioned. It gives out 80% of the data set to x train and y train, and the rest of the 20% to x test and y test. The random state is just a value to get the same number, basically based on all the random numbers in this sklearn, to get the same number regardless of how many we are executing this code. Again, x train that head, x test that head, y train, y test. The length of x train, this is what matters. It shows that the length of x train is 120 rows and the length of x test is 30 rows, which confirms that 80 and 20% percentage. pt.getDummies y train, what it does, it goes through the whole column, take all different values, and does the one-hot encoding. So instead of only one column, we will have 3 different columns because we have 3 different values throughout the column. Take all different values, put them in each separate column, and based on true or false, values it. So as you can see in the results set, if it's 0, if the actual, for example, in 130th row, the value that we had was true in reality. That's why in the first 2 columns we chose 0 or 1, we are getting false. And then in the last one we are getting true. And the rest is accordingly the same. We're defining a model. The model is sequential, which shows that we will have a stack of different layers with different amount of neurons in each layer. Then we are adding these layers in our model, in our sequential model. The first layer would have 100 different neurons, and input dimension is basically the number of amount columns we have in our x train, which was 4. Activation function is ReLU. This is basically what the function that takes the input, and based on this function the output is different values. The second layer is same, 100 different neurons with the same activation function, and the last layer, it has only 3 neurons, and the reason for that is because we had 3 different values in our target column, so that we would like to predict 3 different values. That's why we have 3 different neurons. The activation function is softmax for multi-class classification. That's why we are choosing softmax. Then we are compiling this model. The loss function is categorical cross entropy, and the reason for that is because categorical cross entropy is for different multi-class classifications that are used with one-hot encoding. The optimizer is Adam. What optimizer does is, after each calculation, it takes the loss function, it takes the accuracy, and based on how good that is, it goes through the loop again and change the weights, change the parameters in our model. It improves the parameters values so that it can decrease the loss function. It can decrease the loss function value. The matrix is accuracy that I wish I would know how long it has been passed. We take the summary of model, compile it again with a different optimizer. We're training that model. The train first takes X-train test, and then one-hot train labels. We have 3 different columns in these one-hot train labels. Because basically in our result set, in our Y label, we would need to give out 3 different values. That's why we are choosing one-hot train labels that has 3 different values as of our Y value. Epochs is basically saying how many times this model will go through the whole database to train this. So 20 times will go through the whole database to train this model. The batch size is just a small mini batches, which is separated 10 by 10. So it went through the dataset 20 times and it trained the model. The accuracy and the loss has been changing through each time of training. After all of the training is done, we are evaluating that model based on X-test and one-hot test labels to see how good the result will be for the unseen values through the table. The test accuracy is 86% and the loss is 18%, so it's pretty good. It is not overfitting, it is not underfitting. It's exactly how it should be. So throughout the next different code snippets, we are just changing the number of different neurons in each layer. Over here, for example, 10 neurons. The previous one was 100. So that we can see when we are training this model through different, way fewer number of neurons, how good it will predict. We also change the epoch, the number of times that it goes through the whole dataset. Only 4 times went through the whole dataset to train the model. Evaluated the model, the accuracy is 73%. So it has been decreased by far because the number of neurons was decreased, and also the number of epochs, the number of times that it went through the whole database, decreased. We're just converting this Y-train and Y-test to categorical because it was categorical initially. That's why we use softmax. Over here we are using different optimizer, SGD instead of Adam. Over here we're using Adam again. Different, so each one of these would have a different result. We can see the accuracy over here. The accuracy is so low, even in training. And I think there were some questions asked. I think I explained all these questions throughout my explanation. Number of layers and hidden units. We should avoid having too many layers and having too few layers so that we avoid overfitting and underfitting accordingly. Do we always suffer overfitting? Not really, depending on how much we're training our model and how much the model is memorizing the values instead of learning it. How can we detect overfitting? We can detect overfitting if we are having a very good accuracy in the training set, but we are having a very low accuracy in our actual testing set, which shows that the model has memorized instead of learning. How can we reduce overfitting? There are different ways. Decrease the number of neurons, or decrease the number of epochs that goes through a whole database. Decrease the number of layers. Can reduce overfitting. Thank you for your attention. Hope you have a great day.